Okay, so we're going to start chapter 2 today, and before we get too deep in it, we're going to look at something that you've studied for a while. It's called the rectangular coordinate system, or the Cartesian coordinate system. So let me draw one. This is your y-axis, your x-axis. This is called the Cartesian coordinate system. And the quadrants are numbered 1, quadrant 2, quadrant 3, and quadrant 4. And if you don't remember that, the coordinate system or Cartesian coordinate system starts with a C, so we number them like that. And then they have ordered pairs. So if I go so many lines over, and I call that distance A, and I go, I don't know, so many things up, and I call that distance B, then this green dot over here is an A, comma B, because I want A in the X direction and B in the Y direction. So the point of this coordinate system is that we pair things together. Some examples are listed up here. But the amount of money you put in your bank account and how much money you actually have based on your interest rate are things that we can pair together. Or how much money you have to buy groceries and how many groceries you can buy, things like that. There's always an input-output situation. So the first formula that we're going to review today is the distance formula. And this is, you've probably learned distance formula as the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, which is exactly what we have. The only difference is they put this PR in the front because it's saying it's the distance from the point P to the point R. So let's practice finding the distance. So I have 2 points, P and Q. So my distance between P, comma, Q is going to equal, and then I'm just going to label these to help us a little bit. X1, Y1, X2, Y2. So big square root 3 minus negative 8 squared plus negative 2 minus 4 squared. So on the first one, I get 3 minus makes a plus, so this is going to be 11 squared plus negative 6 squared. Please make sure you put your parentheses because negative 6 squared does not equal negative 6 squared. This would be 36, which does not equal negative 36, so the parentheses matter. So when you do this, you get the square root of 121 plus 36, which is the square root of 157. So let's try another one. Very similar idea. So it says determine whether the points M, N, and Q are the vertices of a right triangle. So one thing we learned about a right triangle, regardless of where in space these dots are, is that if I am a true right triangle and I call this A and B, then this is C. Then we have Pythagorean theorem, which is A squared plus B squared equals C squared. So we're going to find the lengths of each of these legs, and then we're going to figure out if it fits Pythagorean theorem. So they give me M first, so we'll call this one M, and then N, and then Q. So let's find out. So the first thing I'm going to do is the distance of MN, which is going to equal big square root, negative 2 minus 12 squared plus 5 minus 3 squared. This is going to be 14, well, negative 14 squared plus 2 squared. This is going to get me square root of 200, which does simplify, but I'm going to leave it for now. And then I'm going to do, if I made m and n friends, let's do the distance of m and q. So when I do that one, I'm going to get negative 2 minus 10 squared plus 5 minus negative 6, oh, sorry, negative 11 squared. So this is going to be negative 12 squared plus 16 squared. That's going to get me the square root of 400. And then my last one I needed to do is the distance of NQ. That's going to do 12 minus 10 squared plus, oops, 3 minus negative 11 squared. It's going to get me 2 squared plus 14 squared. That's going to be square root of 200. So if you remember anything about a right triangle, or anything about a right triangle, the hypotenuse, the C, always is the longest side. So this side has to be my hypotenuse. The other two really don't matter. I'm going to call this one A, this one B. Actually, I'm going to make it match the picture. In my picture, I have it the other way around. In my picture, MN I called B, and then NQ I called A. So we know if this is truly right triangle that A squared plus B squared has to equal C squared. So square root of 200 squared plus square root of 200 squared, which is my A and my B, has to equal my C squared, which is square root of 400. So if we do this, the square and the square root undo each other, so I get 200 plus 200 equals, oops, I took the square over here, squared, equals 400. And that is true. So yes, this is a right triangle. If Pythagorean theorem did not work out, then no, it would not be a right triangle. Let's try another example. So this example says, determine if these points are collinear. Collinear means they all are going to fall on the same line. In math, we're pretty logical, so I'm going to label the points in alphabetical order and in the order they give me. So if I'm going to fall on the same line, I have a point, we'll call it P. Then I have another point somewhere, it's called Q. Then I have another point somewhere, that's the last point they give me, I'll call it R. So if these things are collinear, then this distance right here, PQ plus QR, should equal the length from P to R. So let's find out. So I'm going to color code, and I'm going to call this distance here the blue distance, so P to Q. So distance of PQ is going to equal square root negative 1 minus 2 squared plus 5 minus negative 4 squared. This is going to be negative 3 squared plus 9 squared. So this is 9 plus 81, which gets me the square root of 90. I'm going to simplify this. 90 is 9 times 10, and I have to square root both of those. So this is the same thing as 3 square roots of 10. So this blue piece is 3 root 10. Now let's find my red piece, right here, red, QR. So distance of Q to R is going to equal big square root 2 minus 4 squared plus negative 4 minus negative 10 squared. So I get negative 2 squared plus makes them minus. So, sorry, minus makes a plus. plus 6 squared. So this is the square root of 40, which 40 is 4 times 10. So this is 2 root 10s. So this distance here is 2 root 10. So what we need to happen now, if these points are going to be collinear laying the same line, is that I need this distance PR to add up. So PR, line segment PR, should equal PQ line segment plus QR line segment. So I should have the 3 root 10 plus 2 root 10. They should add up. So I should end up with a 5 root 10 if this all works out. We're going to find out. So this big distance is my green distance. So I'm going to do the distance from P to R, not P to Q. P to R equals big square root -1 minus 4 squared plus 5 minus -10 squared. So when I do this, I get -5 squared plus 15 squared, which is 25 plus 225, which is square root 250. And 250 is 25 times 10. Square root of 25 is 5 root 10. And you can see that this, it matches this, so yes, they are collinear. Let's look at another formula. So another formula that you have used a lot is right here. It is the midpoint formula, and the midpoint is the middle between two dots. So if I have a dot here, and I call this dot x1, comma, y1, and then I have some other dot over here, x2, y2, the midpoint, the middle of them is the average. The average is the middle of something. So to find an average, you add them up and divide by 2. So to find that point, you're going to do x1 plus x2 and divide by 2, comma, y1 plus y2 and divide by 2. And that would be the point or the ordered pair. So let's try it. So it says, find the coordinates of the midpoint of this line segment. So here we go. x1, y1, x2, y2. So my midpoint is going to equal, it's an ordered pair, 8 plus -6 divided by 2, comma, -4 plus 1 over 2. So 8 plus -6 is 2. 2 divided by 2 is 1, comma, -4 plus 1 is -3. -3 divided by 2 is -3/2. So the midpoint between those two order pairs we were given is 1, comma, -3/2. The next problem is very similar to what we just did, but it's a little bit backwards. So make sure that when you're doing your problems, as always, you read carefully. This one says, find the coordinates of the other end point of the line segment. So here's one end point, but this is my midpoint. So let me set the equation up. So my midpoint is always going to equal x2 plus x1, or x1 plus x2, doesn't matter, you're adding, over 2, comma, y2 plus y1 over 2. And this equals my midpoint. I call it xm, ym, my x midpoint y, or my x and y parts of my midpoint. What they gave me was this, we'll call this one x2, y2, but this over here is my m's. This is my xm and my ym, so I need to solve for the other endpoint. So let's do that. So this x piece right here has to equal this x part of the ordered pair. So I'm going to do -6 plus some x1 that I don't know over 2. and that has to equal my midpoint part of my x, which is 8. So I'm going to multiply the 2 over. Negative 6 plus x1 equals 16 because I multiplied the 2 over, and then I'm going to add the 6 over, so x1 has to equal 22. So that's the x part of my midpoint. Similar idea for the y part of my midpoint. 12 plus y1 over 2 should equal the y part of my midpoint, which was negative 2. Same process, multiply the 2 over to the negative 2. So 12 plus y1 equals negative 4. And then subtract the 12 over. So y1 is going to equal negative 16. So my other point was 22 comma negative 16. These are Q's and points. Okay, the next thing that we have always looked at in the coordinate system is graphing. So we taught you about this coordinate system, and then we graphed. So we're going to graph finding the intercepts. So let's make a note about intercepts really quick. So if I want to find an x-intercept, these are all x-intercepts, all of those. When you're finding an x-intercept, you let y equal 0 because these dots have a height. They've gone up and down to 0 units. But if I want to find a y-intercept, all of these are examples of y-intercepts. These dots have all gone side to side as 0, so we let x equal 0. So if we go down here to this first problem, it says that step 1, I should find the intercepts. So let's do that. X-intercepts, y-intercepts. So to find an x-intercept, you let y be 0. So 0 equals 4x minus 1. Add the 1 over. 1 equals 4x. Divide by 4. So x equals 1/4. That is my x-intercept. So if I go to my x-axis, I should have crossed it at 1/4. For the y-intercept, you let x be 0. So y equals 4 times 0 minus 1. 4 times 0 is 0 minus 1. So my y-intercept is negative 1. Right there. So I've done step 1. I found the intercepts. Step 2 is find additional ordered pairs as needed. Plot the points. I've done part of that. And then I'm going to find another ordered pair or 2. So I don't know. If we look at our graph, maybe we want to know what happens when x equals 2. So if I want to say let x equal 2, you can pick any point you want. But if I let x equal 2, I get y equals 4 times 2 minus 1, which is 8 minus 1, which is 7. So I have the ordered pair. I plugged in 2 and I got out 7. So at 2, I should be at 7. So if I try very carefully, this is a line. Hopefully you recognize that as y equals mx plus b. It's a line. So I try to do this. Not the world's best drawer. But there is our line. Okay, so we're going to do this 2 more times. Okay, so let's do the next one. If I go find the x-intercept, we let y be 0. So x equals square root of 0 minus 1. X equals square root of negative 1. That's an imaginary number, so there's not going to be an x-intercept. Y-intercept, you let x be 0. So 0 equals square root of y minus 1. We're going to square both sides to get rid of that square root. 0 equals y minus 1. Add the 1 over 1 equals y. And then we are going to plug some things in. So normally you can make a table or plug things in. And honestly, normally we plug things in for x. But if you look, since the x is by itself, it's probably easier to plug things in for y and then solve for x. So something that I can take the square root of, I already have the y value of 1. So something else I can take the square root of is 4, which means I need the y to be a 5. Because 5 5 minus 1 will make 4. Square root of 4 is 2. And it's only the positive root because the root was already on the paper. There's no plus and minus in front of it, so it is just the positive or the principal root. So at y equals 5, I'm at 2. Something else I can square root is 9. So that means I need y to be 10 because I need to subtract 1. 10 minus 1 is 9. Square root of 9 is 3. So at 10, I'm at 3. And so I have this graph like that. One more. Hopefully you recognize this thing as a parabola because it has an x squared, but let's find the x and y intercepts. So for my x, I let y equal 0. 0 equals x squared minus 4. Add the 4 over. And then we're going to put a square root on the paper. And because we made a square root up here, we have to do the plus and the minus version. So, oops. Let me try to write that one more time because I wasn't paying attention. So plus and minus square root of 4 equals x. So plus and minus 2 equals x. So I have two x-intercepts at -2 and at +2. Y-intercepts, you let x equals 0. So y equals 0 squared minus 4. Y equals -4. And if we wanted to plug in 3 or something else, we totally could. Plug in 3, so you're going to do 3 squared minus 4, which is 5. 3, 5. And since we know this is a parabola, it's symmetric, so even if I plugged in -5 or -3, I would also get out 5. And this is your parabola.